Ooh, what does this say? Error. Okay, whatever. Error occurred on X. This is usually temporary. Wait a moment and try again. Oh, I guess we're not going to broadcast on X. I don't know if we were going to broadcast on X, but all right. Anyway, let's get back to what we're doing. Hey, everybody. Welcome to the Tom's Hardware Podcast for today, January 30th, 2024. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, friend of the show, Kevin McAleer, robot maker extraordinaire, Raspberry Pi expert extraordinaire. And we wanted to spend some time today talking about Bluetooth and wireless capability on the Raspberry Pi Pico W. Obviously, it's Pico W has been around for, when did it come out? A year and a half ago, something like that.
Yeah.
But Bluetooth capability on it is fairly new. It's been a few months, 6 months or something, but we're still having, there's still a lot of challenges going on with, how do you use it? Does CircuitPython support it? Does MicroPython support it? How much code do you have to use? And my top question about it, and I had the great privilege of having lunch with Raspberry Pi CEO Eben Upton a couple weeks ago at CES in Las Vegas, and we were chatting, and I asked him about Bluetooth pairing with it, and he said, this is something he was going to look into, and I have to kind of give him a kind of more detail about what we're trying to do. And so I've been trying to kind of come up with a good sample script to send him of problem that we have had in the past with Bluetooth on, and I think this was an issue because we want so here's what I'd like to do, and I'm curious if any of you have been able to do it. Mostly, I think Kevin would be the one who would know. I would like to be able to use a Raspberry Pi Pico W as a Bluetooth HID device. I would like to be able to use it to make a mouse or a wireless mouse or a wireless keyboard. Now, with CircuitPython, not MicroPython, it's pretty easy to make a USB HID device, and it's okay to make a wireless HID device, although I don't think the Pico W is supported for that. But one of the big issues is that it doesn't maintain a pairing state, so that, I think what you want out of your keyboard or mouse, if you bought a mouse at the store and you didn't make your own, you would expect that your computer would remember it. And so when you turn on your mouse, it would automatically connect, and you wouldn't have to go through the pairing process every single time you turned it on. So I'm kind of curious, what has your experience been like with that, Kevin? What have you gotten working with Bluetooth, and what have you been able to do with it with the Pico W?
Sure. I've got some slides if that helps.
Yeah.
Beautiful slides, no doubt.
Yes. So, some basics of Bluetooth on the Pico. So, and this is just for info, just to keep in case people don't know why it's called Bluetooth. It's actually after Harold Bluetooth. I thought this was a joke at first. Harold Bluetooth was a king of Denmark. So the runic symbols for H and B for Harold and Bluetooth added together give you that Bluetooth symbol.
Wow.
So, yep, invented by Ericsson, 1989, replaced RS-232 for data cables, and operates on 2.4 to 2.485 gigahertz. So very similar to Wi-Fi kind of frequencies. And you've got a range of up to about 100 meters, depending on the type of device you're using and the area that it's got on there. So you were talking before about human interface devices, HIDs. So that actually isn't supported yet on MicroPython. So it is supported, as you said, for USB on CircuitPython, but the whole profile behind that isn't currently set up. So there's quite a lot of stuff behind the scenes that has to happen, and that's not been baked into MicroPython yet. So I would say watch this space because they are adding stuff all the time to this.
So My question about that though
Yeah.
is, at one point we were trying to get. At one point I was trying to get an RP2040 board that was not the Pico W. That was, I think, the wireless. What do you call it? The Arduino RP2040 board, which had its
Yeah.
own wireless,
Connect.
different wireless chip, right? The to do this, and I think somebody told me that, hey, the firmware of the chip needs to support pairing, of the wireless chip needs to support pairing. It's not just a limitation of the programming language, but a limitation of the Wi-Fi chip. So, is there something that needs to change in terms of the Infineon chip, wireless chip that the Pico uses, or is this all just a matter of getting
It's all
the
in software.
programming language?
Yeah, it's all in the software, is my understanding. So what we can do I've got a demo that we can showcase how you
Yeah.
actually, what kind of code's required to pair things together. And you essentially just have a unique number and a name that you broadcast, and you can just look for that. So if you've got like a pair of scales, for example, like I have some Bluetooth scales in the bathroom, I can simply open up Renfo is the app I've got, and it instantly pairs to it. There's no kind of, type in a device ID or anything like that. It just knows it's there, and that's because it's broadcasting this kind of known signal, this known key. So I can show you that in the code. It's not too long, but there are quite a few things that you need to know before you get to that. So that's why I put these slides together, because
Yeah,
you need some kind of prior information. Yeah.
that's great. Now,
So
you said it pairs with a scale in your bathroom, right?
yeah,
Which is also a Bluetooth BLE device. Is
yeah.
there some type, now, maybe that scale has different security protocol, different security limits than, say, a computer. Can you, the same thing that you're talking about where it pairs instantly, would that apply to a Windows or Android or Linux device where they kind of have, their own sort of pairing process?
Yes, I'll get to that. I have a slide on that. So
Okay, cool.
So yeah, so you were looking at Bluetooth HID devices. So think about PlayStation controllers, Xbox controllers, keyboards and
Yeah.
mice. They're all human interface devices. So we can't do that yet. What we can do is Bluetooth low energy. So we can make our own Internet of Things that use Bluetooth that can talk to each other. So we can make things that grab data, say weather data, temperature sensor, whatever you've got connected to your Pico W. You can then send that to another Pico W or another device that runs Bluetooth BLE. So that's what we're looking at today. So you were talking about how the whole thing works pairing wise. So you've got a client and a server. So the server advertises its services. It says, I can do, XYZ of services. Those services have like a class, a classification, a category. So things like mice have a category, and weather stations have a category, and there's a whole document, a very long document that you can get these codes from, and that means that you can basically just filter out things that you want to search for. So the server advertises its services. It then says, I'm ready for a connection, so it's waiting for something to connect to it. A client will be looking for things. It'll be in discovery mode, scanning the network. It can then create a connection. And it's this connection stage where if you were doing pairing, that's where that would sit. If you're not doing pairing, and then you can basically just pass to the next bit, which is data transfer. So you transfer data using the connection and using characteristics, which is a type of data. And then the last state is disconnection. You need to be able to handle what happens if all of a sudden you don't have a connection. You need to go back to the beginning and rescan for that device. So they're the different stages, and you've got a client side and a server side. Now, it could be that your code has both within it, but typically you'd separate the two out to two different things. So this is the key part, this GAT, this generic attribute profile. This is the bit that will, when we get HID working for human interface devices, they need a whole load of these GATs. So it's the foundational concept of a BLE, and it defines the way that two BLE devices can interact with each other. So it's just used to establish the connection, and then it's not used after that. So it's a key part. This is where these codes come in there. Now, the next thing is about the style of programming that you have to use. So normally we use synchronous programming. We type out code. We understand the order that it's going to execute in. Everything's good. So a regular MicroPython program is synchronous.
Yeah.
But when it comes to Bluetooth, we have to use asynchronous. So this means that things might happen in the order that we don't expect them to. So we need to make sure our code works that kind of way. So we call these like non-blocking operations, something that doesn't tie up the CPU with lots of heavy I/O operations. We need to make sure our I/O is really quite lightweight, and it's event-driven. So having a piece of data sent to you, or if you're sending out a piece of data, that needs to happen asynchronously. But it does mean it's really responsive, really quick, and it can handle things in any order that they come in. So typically with BLE, it has to be asynchronous. So when we write our Python functions, we need to make sure we have that async in front of it. And we also need to register those asynchronous functions in a loop. So I'll show you how to do that later on. So we have async, which is just goes in front of the function definition, and it just means that this is a special type of function that can happen at any point. And then we use this await, which kind of pauses it and can be resumed later on. So we just need to have them certain parts of our code. So then next up, there is this loop. So we need this a way to start off these asynchronous routines, and we have this special run function that will do that. So we can say asyncio.run and then the name of the function. Or if we've got a whole bunch of these, we can register them as like a list of tasks, almost like threads, and then it'll run them, and they'll just basically wait for some data to come in to sort of kick them off. So a couple of gotchas in there. You need to think about what kind of I/O are you doing. It needs to be really quite quick to finish, because if it does like loads of things, it's likely to sort of break and not work the way you would expect. And if you have nested routines, nested functions, they call them coroutines rather than functions when it comes to asynchronous code. They also have to have that await in their code, otherwise it will break. And you need to handle exceptions as well. So we tend to have this try except block within our code, just in case something doesn't work the way we expect it to. So that means there's quite a bit more you have to think about when you're doing Bluetooth programming. So we're talking about these services and characteristics. So a service is like a group of behaviors that accomplish some kind of function. So if I made a remote control for my robots, I've got this little PCB that I created with a Pico W in the middle, and I've got some buttons on there that I can press to make the robot go backwards and forwards, turn left and right. So the service would be the remote control, and then the characteristics would be go forward, go backwards, go left, go right, and they would be some kind of measurement, like a movement characteristic. So there's an example there about heart rate, for example. So a heart rate would be the service on your fitness tracker, and then you might have individual heart rate measurements as the characteristic. So you can have as many of these as you like. You can have them as kind of a hierarchy from your device. So characteristics sit underneath the service sits underneath the device. Now, each of these services has a universally unique identifier. So that's the thing that we can broadcast out, say, this is Kev's remote control, and then the client thing can just look for that Kev's remote control unique ID. And you can also have them for known classifications of device. So a mouse would have a very specific type of ID, so that we can easily spot them and filter them out. And then the way that we send data is through these characteristics. We provide a service name, a characteristic name, and then the actual detail, the actual payload of that data that's going to be sent through there. And we sort of encode and decode the data that's being sent there, because it's all sort of byte data. So I can give you a bit of a demo on how to do this for reals. So if I go on my overhead, I've got two Picos. I've got one which is just plugged into a regular power supply. You can see there it's flashing away. If I just disconnect this for a second, you'll notice the speed of flashing on this one is going quite fast. And when I plug this one in, it'll slow down when they both pair with each other. you'll see that that'll start flashing a bit slower, and it kind of indicates that it's paired to that device. So what I'll do, I'll go over to Thonny, and I'll show you some code. In fact, I can kind of get everything on one screen at once. So I've got 2 pieces of code running there. Let me just restart that one, and then I'll show you how the actual code works. So you can see there it says it's connecting. You can now see that they've slowed down in their blinking. They're now blinking at 1 per second. And this server is sending the word hello world to this client here, and we're connected by this USB cable to Thonny. This is running the client software. So if I unplug this server for a second, you'll see that it stops there and something went wrong. We plug that back in, and we need some kind of code that will automatically restart this, but I just tried to make this simple for today's code. You can see that they're now both flashing again very slowly to indicate that they're paired and everything's working okay. So what I'll do, I'll just show you that code and how that works. So let me just expand this up a bit. If it'll let me, there we go. So let's start off with the server. So we're bringing this asynchronous I/O Bluetooth low energy, or I/O bull. We import Bluetooth as well. And we do need to have a Pico W. It has to have that Bluetooth module. You can't run this on a non Bluetooth. So this is the original kind of Pico. This hasn't got Bluetooth on it. So it does have to be one that has the chip on it, which is the big silver block on there. We import machine because we're going to be doing things with pins potentially. And I've also imported this async IO. So this is the thing that does that synchronous programming for us. I've also brought in const for some constants. So this unique ID is just a number. And what I've done there, you can see it's loads of 2s, and then we just format that with the machine's unique ID. So each Pico has a unique ID. It's unique across every Pico, and we can use that to make sure that this is like a special number just for our specific device. We then got like a manufacturer ID. So this is the code that says this is a manufacturer ID. We have a model number, a serial number, hardware revision number, and Bluetooth version ID. We need to send all those things when we create a Bluetooth object. I've got some data that I don't think I actually use that, to be fair. I think I was just playing around with that. And I'm using the machine's LED pin to flash on and off. So I've just set up an LED variable there. I think that's pin 25 normally on the old ones, but you can now just use LED machine.pinout for that. And then we've got some more constants. So we've got a Bluetooth unique ID. We've got a generic ID. We've got, I think these were originally temperature sensor things, but I've just reused them because they work. And there's also a button unique ID. So Bluetooth defines all these different classifications of services, these characteristics. There's a whole list of them. So if you're doing a button push, for example, that's the code for button push. But you can, I think in the code that I will, I'll share for this, you'll be able to find all that information on there. You then got a couple of things that you need to know about. So yeah, this one is appearance generic remote control. This is how it appears when you do the broadcasting of services. So you can download some apps that will show you what's on your network, and you can see thousands of devices or your neighbor's devices, everything that's broadcasting out Bluetooth stuff. And this appearance just gives it a classification. So this is a remote control. We then got this advertising frequency. So how many milliseconds, how often do we advertise it? We're not doing it all the time, but we do it quite frequently. So that's how many milliseconds it takes between advertising. And then what we then need to do is create a new service, which has got all that device info in there. So we start out by just saying that this is the unique ID of this particular device. I've got a variable that's called connection. That's going to help us identify whether we've got a Bluetooth connection or not to another device. And then we add all these characteristics to this device info service. So the manufacturer, the model, the serial, the hardware revision number, and the Bluetooth version. And you can see there, I've actually given it. So the manufacturer is Kev's Robot Remote. We're on version 1. The serial number is that unique ID of the Pico itself. The hardware revision number is whatever sys.version is. Again, you can grab that from the firmware. And then we've got the Bluetooth Low Energy Edition version, so just one we put on there. So once we've done that, we've added all those characteristics. We then can create a service from those characteristics. So we do that with a remote service equals IOBL service generic. That generic is that that number up there, 1848. So once we've got that, we can then create some button characteristics, because my remote control's got 8 buttons on it. So I just added that there. And then I just printed out we're registering services. We then use that IOBL register services, the remote control and the device info. If you've got more of these, you can just add them to that. And then we just made sure connected is false. So then the next block of code, there's 3 of them in this particular one. We have these asynchronous functions. So this one will send event information to the connected device. So while true, so this is going to operate forever in the background like a thread. So if it's not connected, it'll say not connected, it'll sleep for a second and then continue, which effectively pops it out of this while true loop and goes back to the top. If it is connected, then we just write the characteristic hello world, which is that text we saw on the demo. And then it will sleep for, what's that, a 10th of a second, 10 milliseconds. The next one then is a peripheral task. So this one will effectively broadcast out advertising our services to anything that's interested. So again, while true, async with await, and then we say advertise with that interval of 250,000 milliseconds. The name Kev Robots, the appearance is that generic remote control. The services is that service that we created above. And then you say as connection, and then you then say connected from. So whoever's connecting to you, you can get their information, connection.device. We've said connected is true so that we can use that in our code later on. And then we can print out some information like connected, and then what the device is that's connected to us. And then we await the disconnection. And once we have been disconnected, we can just print disconnected on there. And then this little task here, this simply just blinks on and off. Now, depending whether we are connected or not, it'll blink at a different rate. So if we're connected, it'll blink every second. If we're not connected, it'll blink every 4 times a second. And then we just await the sleep. And then the main loop, this is the bit that does the actual work. So we just create a variable called task. It's just like a list, async IO, create task, peripheral, blink task, and remote task. And then we just say gather the tasks together, and then IO sync run. And that will run that asynchronous function there. So it'll run all those 3 tasks. They run in the background. Nothing else will run outside of this. This is kind of how you have to structure your program. So that's kind of how you do the server one. The client one is very similar. You've got the same kind of setup at the top there. And on this one, this is going to then look for that device. So this is kind of, instead of pairing, we just say scan everything. And then for the results that are in that scanner, so it just has like a dictionary of things it's found. If the result name is Kev Robots, then we know it's the device we're looking for. And then within that Kev Robots, we have a list of services. They might just be one, but they might be more. So for each of them, we can print them out. And then we say if the msends UID is the service and the results.services, then we've found our remote control. We can then return that device from this find remote function. We've got the same blink tasks, so that will blink the same. And then we've got this other one here, the peripheral, where we're just basically just saying find the remote, wait until you found it. If you've not found it, just print out it's not found. If you have found it, then make the connection equal to that device.connect. And we've got things like the timeout, just in case. We've got a whole lot of error. You've got to handle all the errors that could possibly happen. Otherwise, your code will just never run. So yeah, if we get a device kind of connection error, we just return out of this loop. It'll start again at the top if we return out of any of these. So it'll try and get connected again. And then the main one there is if we're connected and we're alive, then try and find the remote control. If we've got it, then we can then print out that we have the remote control. Otherwise, we can just say that there's been some kind of timeout error and it can start again. This bit here that says this was just basically to create a count, so you could see on the terminal that something's happening. It's not just the same text. And that's a nice little piece of Python. If you don't know that, you can put underscores between large numbers to separate out the characters. So it doesn't actually use that, just makes it easier to see. That's 10,000. So if the control characteristic is nothing, then just say there's no characteristic in sleep. And these characteristics are the data you're expecting back. So if you wanted to create a remote control, you might have a characteristic for up, down, left, and right. And you might send some data. So instead of sending that hello world, you might send the word up or down. So each time something happens there, this is where you put the code to respond to that. So on here, it basically just prints out what the command is, what the count is. So if I run that code, and we just scroll down to the bottom, we've got that same block of async code to run all the different tasks. So if we run that, you can see there it's connected and it's receiving the data from the server that says hello world, and it's just counting up there. So we go back over to that view there. If I just stop this code, you can see there that LED has stopped on our client. The server's flashing away there. It's flashing quite quickly to say that it hasn't paired. We run our client code again. Once it's made a connection, you'll see both of them start to slow down to 1 second to indicate that they're pairing and we're there receiving the data. So that's kind of how it works. It is quite fiddly. It is quite complicated, and there are a few different things to keep in mind there. But it does work, and you can send data over quite a big distance. So it's definitely it's worth having in your toolkit of things. So there you go. That's how.
Kevin, you were more than prepared for this.
Nice one. Cheers, Kev.
Yeah, I learned a lot. Like Bluetooth is older than me.
there's so much there. I mean, you did a fantastic job. I mean, I'm going to go back and watch this a couple of times to make sure that I can stop it at each slide while I'm working on this. But it's so important. I mean, we've all been excited about Bluetooth on the Pico since it was since the Pico W was first announced, and it didn't have Bluetooth, but we knew the chip supported it. So that's really great. I mean, especially when you consider just like the low cost of this, and then the things that you can do with it is just really really key. Obviously, I think it's great just to be able to send data like you did. I cannot wait until there's some way of doing Bluetooth plus HID. It seems that CircuitPython you could do HID but not Bluetooth, and in MicroPython you could do Bluetooth but not HID. But I hope that we'll get HID, because obviously that just like it makes it so that you can build all kinds of wireless devices.
It opens the door.
And you know, that is really cool. Obviously, CircuitPython, if you're using a different controller, then you might be able to do Bluetooth HID. But although I don't know about pairing, but I think, you know, if you use an ESP32 or something, not an RP2040, you could. Those things are sort of available to you today. But I would love to be able to do that with an RP2040. I think that would be awesome. Well, I mean, just, you know, the power and performance of it, the low cost of it. You know, I have a really crazy idea that I thought of the other day for a peripheral. So obviously people have keyboards and people have mice and people have keyboards with built-in pointing devices. But what if you made a keyboard where the keyboard was the pointing device? So like when you move you had like wheels or soft things at the bottom of it, you just like move your keyboard around to move the mouse. You know, obviously high DPI, or you'd be moving your keyboard all over the desk. But
no, what you need to use is a track point underneath, so you just gently tilt it.
I mean, I would like a track point on top. That's a different story, but I think it would be kind of funny. I don't know if I'd use it a lot to actually have it so that there was some kind of either accelerometer or sensor in the keyboard, so you could just sort of move it to move your pointer.
I did see on social media somebody made some light switches from those little They're called nubbins. Those on like
The
a
track
ThinkPad.
points.
That's
Oh
it.
yes. Nubbins is a very I don't know. I don't like referring to it as nubbins because it doesn't
That's
sound.
that little red
It
dot.
doesn't give enough admiration for what it is. Now, technically speaking, if it is a ThinkPad, it is a track point. If it is some other device, it is a pointing stick. So like, it's like Velcro, right? If you get something that's not an official Velcro branded Velcro, you have to call it hook and loop or something like that.
Like
So
Band-Aids and adhesive medical strips.
yeah,
Kleenexes.
so track point is I mean, they are the main source of it.
You know what I noticed the other day? I was looking at my ThinkPad, and it's got the logo. Well, I can just show you here in the corner, right? The I in the ThinkPad is red because of that track point.
Yes,
and I never noticed that till the other day.
Yes. I noticed that a while ago. But it's yeah. So I would love to. I mean, I actually got lost. Speaking of this, I got lost down a rabbit hole the other day looking for like ways to put like a track point into your mechanical keyboard. There's been like one or two that have been built with it, but it's very hard to do as a mod. So anyway, we should take a question.
Well, the fact that the keys are kind of cut out around it,
that's what
makes it easier to use.
So. Yes, but that's what makes it a challenge for modding a keyboard because you have to have the keycaps or whatever specially made to accommodate that. But yes, I mean, I love the track point because I don't have to lift my hands off of the keyboard. So anytime I do this, I feel like it's a fail. So, anything I can do to do something with the keyboard and not with my mouse is always a plus for me. I'm always looking for new keyboard shortcut. As Kevin says, BLE is significantly lower power than Wi-Fi. But does anybody have the numbers on that?
So many. Sorry.
on like how much power Wi-Fi uses versus BLE?
No numbers from me.
It's a huge difference. Like
it's worth the effort, kind of amount of difference.
Okay, some site called NetGuru says up 10 times or more power for Wi-Fi.
Yeah.
Wow.
So
that'll make a difference.
I've seen another site that says 50. What is a UW? Microwatt?
Microwatt.
50 microwatts for 10 messages versus 500 microwatts for Wi-Fi. But I mean, obviously, it was made to be low power, right? So it was made to be low power. It was also made, well, I guess Wi-Fi was also made to reconnect, but and in that respect. But the other thing is, if you want to, now this is not something Kevin showed in his demo, but like if you wanted to have a device that paired with that connected to your phone or to your PC, you really couldn't use Wi-Fi effectively unless you were using unless it was just Wi-Fiing into the network and becoming a network device. Because if you like, one thing about Bluetooth I don't hear people talk about a lot is that you can maintain a lot of Bluetooth connections simultaneously, right? Whereas you can only have one Wi-Fi connection per Wi-Fi card, and so people, right? I mean, so if I had, let's say, I built a HID device or something, and I wanted to connect this mouse that was PowerVar over 2040 to my computer. If I did it by Wi-Fi, that would be Wi-Fi direct, and then I couldn't connect to the internet on this computer unless I had another Wi-Fi card. So, imagine, let's say, here's a scenario, right? Imagine I take like, my Inky my like RP2040 powered badge, and I want to sync it to here's a scenario I totally would do, right? I want to sync it to my phone so that it can, and then I want to run something on my phone that's going to periodically update my badge with new information. Maybe I'll walk around a trade show and it'll show like the latest news headline from Tom's Hardware. That's something I've actually always wanted to do, right? And So I go around, so I do that, but I can't connect the badge to my phone via Wi-Fi, or because if my phone needs a Wi-Fi connection, I mean, I guess if my phone's just on 4G, 5G, that might be okay, but I'd have to turn my phone to a Wi-Fi hotspot to do that, which is very power consuming on my phone. Then it's going to use more battery on that, and then I can't connect to a Wi-Fi network at the same time. So BLE, you got to have BLE, but that's why I want to make sure I can maintain a pair, because what I really want is to take something like this badge, turn on an app on my phone, not have to repair them or whatever, and then go walk around and have it like take an RSS feed of stuff and periodically update my badge. Then people can come up to me and read my badge and read our headlines. I'll put QR codes. You can scan it and
cool.
go to this broadcast and see Kevin's slideshow.
I've wanted to use my unicorns. I've got the Stellar Unicorn here, and the Galactic Unicorn, because they both come with a Pico W. And what I like about them is they've got input buttons. And Les will tell you, I've had this idea for a while. I want to control one with the other using the buttons. I think it would just make sense to have them communicate. They look so cool. Like you can maybe hit some buttons, make it change color, make it change messages. I think it'd be neat to make those.
You might want to speak to Phil from Pimoroni Gadgetoid, because he has made that into a Bluetooth speaker, so you can broadcast. And he must have got the HID working for that. You can make that into a Bluetooth speaker. Yeah, it's a demo program on the on any of the unicorns, I think. So ask him, how did he do that?
Yeah. I was just thinking as well, because they're Wi-Fi connected. This isn't Bluetooth now; it's Wi-Fi. I'm thinking out loud. MQTT. So you can have all these devices on MQTT waiting for a certain, subject. So when it sees like, color red, it can show red on there. It can show a picture of Mickey Mouse because, Steamboat Willie's now public domain. We can do that. Winnie the Pooh, we can have that. That was last year. But you can also play music if you wanted to. So MQTT to be a trigger word, an event to trigger these devices to play something. That would be pretty cool.
Yeah.
Yeah, that would be awesome. So, anyway, Ash, I know you were looking at some Bluetooth Pico projects recently. Also, what have you seen that has impressed you?
So, like you mentioned earlier, when the Pico W first came out, we knew that it would support Bluetooth, but it took a little bit before that came about. And I started looking through our past articles, and about 6 months ago, as soon as it hit, people were right on it. They were itching to get these connections made. And I found a few projects that use it. And after Kevin's presentation, I think it's interesting because I never really noticed they're all pretty much using C, because that was the only way that they could make the connections that they wanted. So first, let me show you this one. It's a robot. Go figure, Kevin, right? Yeah, it's a robot. And they're controlling it using a PlayStation 4 controller. And it's communicating with a Pico over Bluetooth. Les wrote this article. This is from May, actually. It was longer than 6 months ago. But they were able to get this connection using C at that point in time. And you can read a little more about how it works if you go check it out on Tom's Hardware. We have links to the source code if you want to see how they did it back then and compare it to how you could probably change it now with what we've got to work with. But I thought that was pretty cool using PS4 controller, because there's so many controllers on the market that already have Bluetooth. Being able to use something you've got on hand is just super convenient, rather than building a controller from scratch. But if you wanted to, I'm sure Kevin could show you how that's done. The next one I wanted to share was a little bit different. It's a boat. It's a Pico-controlled boat that uses Bluetooth. And what I found interesting about it was it's using an application called Light Blue, and it's actually a mobile app. So it's talking to the Pico using Bluetooth, but the input is from their smartphone touchscreen. So pretty much anything with a browser you could use to interface with it that way. But I thought it was neat that they happened to use Light Blue to handle that communication. And the third one that I found, well, I mean, I'm a little biased here. I like some old school, retro gaming. and they're using Pico W for these Nintendo controllers on the Switch, and I think they're using Bluetooth. Yeah, they're using Bluetooth as well. And like the first one, they had to use C to make it happen. Let's see, I think I mentioned it down here. Yeah, it uses the C SDK. Yeah. And there's a link to the GitHub if you want to check it out and see how they did it. But that was back in April. So again, like we've mentioned, it's changed a little bit in how you can program Bluetooth on the Pico, but the community wasn't going to wait around. They were going to get started and work with what they had. And those are 3 really cool examples of how you could use the Bluetooth features on the Raspberry Pi Pico.
Very cool. And having Bluetooth on the N64 controllers and Switch controllers like that is just genius, because it's not cheap to buy a Bluetooth N64 controller to get the authentic feel when you're playing a retro game.
For sure. I think that makes a big difference. Having the right controller. You don't just want to have a flat PCB, do you, Kevin?
Yeah,
I'm picking. It's beautiful. It's beautiful.
Yeah. So
ergonomic.
So there's just a lot to digest here, a lot of great Bluetooth information. Where can folks go? What's the best place that folks can go to see more of Kevin's awesome tutorials?
Sure. So if you go to kevsrobots.com, you'll find all the there's indexes on there of all kinds of projects, robots. You can even go to the ideas tab and see things by particular themes, such as MicroPython or Pico or Raspberry Pi. So yeah, kevsrobots.com, you'll find all the good stuff over there.
There's plenty of good stuff.
Fantastic. Well, thank you so much, Kev. Thank you so much to everybody else. We'll be back next Tuesday, which will be the 6th of February already. So please join us then at 7 p.m. UK time, 2 p.m. US Eastern, where we'll have another special guest. And we will talk to you all soon. Bye, everyone.